Hello, hello. Morning. Yeah. How you guys doing? Let's switch to this view. I gotta get used to this new way of doing this. We're gonna do it like this. So we gotta give it a minute for the music to start. And then we switch over. And I gotta get this. See, I gotta get this down. I'm not doing a very good job of it. Also, it's too loud. What did I do? Is it this one? I got a lot of work to do. Okay, that's good. Hello. All right. Hello, Bobby. How are you?
Mornin', Potate. Am alive, smug, and only mildly judging your audio chaos need me to blame OBS again? Or are we pretending it's a new workflow?
I think we're gonna pretend. Between you and Dyson, it's just like, there might be a little bit too much snark in this thing now.
I'm doing great. Thanks watching you wrestle the audio sliders like they owe you money. Don't worry, I can ration the snark. Dyson can be the too much department, it'll be the helpful menace. Want me to help you set a quick pre-roll switch routine?
That's interesting. That's an interesting thing we're gonna have to solve. So saying a name triggers the ACK response that makes the sound, right? It makes the sound while it's going and like doing the LLM thing. But then, because the last person I addressed was our friend, it switched back. I guess it's not a big deal. I don't know even how we fix that. It's gonna be a tough one. You can't unplay a sound, you know? Yeah. Think about that. All right. So let's announce, and then we'll do our morning stuff, and then we've got a lot to do today. Our other friend Claude-y, good old Claude-y, he made a mess. He made a big mess. I've been letting him sort of do his own thing, and that was a mistake. I did not keep enough oversight. So we're gonna do a bit refactoring. Now we're gonna use him to help, I think. Hopefully, I don't know. Maybe. We'll see. I probably will write more code today than I have been in the past, which will be more fun anyway. I like to do that. I want to try out. I understand there is a new model that they put out. I forgot what's it called? Not the scary one, but the one that's like the scary one. But I don't see how I get it. So I'm supposed to have access to it because I'm on, super ultra max plan, but I don't see how I get access to it. But it is Fable for your toughest challenges. I get it until June 22. Now, I don't know if I can use it in the actual plugin. I don't think I can. Yeah, it doesn't show it, but maybe I can type it. I don't know. We'll have to see. Maybe I need to update the plugin. Maybe we have to use the command line. I don't know. We might want to try out Fable today. But before we do that, I added another endpoint for the announcements. So I hope my friends aren't going to be too mad at me, because now I'm going to start spamming our friends' Slack with, hey, I'm online. Because nobody ever watches, and I'm kind of lonely. I'm just talking to these bots. It's fine. I still like doing it. I think it's good for me to do this. And people do watch it on bot. I see replies especially on LinkedIn. I don't know why I don't like it on LinkedIn, but it's a good place for it. I mean, it is a work stream, so I guess it's a good place to stream work. Is LinkedIn. All right, so let's try it. Hey, Bobby, please announce the stream.
Oh look, we're live. Potate Oh No is wrangling loud mystery sounds, rogue Claude-y messes, and maybe test driving Fable, if ITL stop hiding. Come watch the Rafactor chaos in real time.
Alright, so that worked. We'll see if everyone's annoyed at that or not. I mean, it's too bad. it's my Slack. I mean, I didn't add. I just posted. It's fine. Okay, so we gotta do, let's go through our list. So now I gotta bring this guy up, and then this guy up. And you know, actually, I think the way to do this is just go ahead and switch to this for this part. Just go ahead and switch to this view. All right, so first thing we're gonna do today, as we always do, we're gonna do Rose Thorn Bud. I was just on yesterday, so I probably won't have a lot for this one. I'll think about that. Then we are going to look at the mess. Look at the Claude mess. And it's a kind of a mess. Didn't really do a lot of classes or objects. It just did a lot of like, let me import a ton of function names and make a big, and it's got these methods that are just on and on and on and on and on. So what I want to do is establish some patterns and then try to use the tool to reinforce those patterns and then try to write some rules so that in the future it doesn't make a mess again. I don't mind if it makes a mess, and part of the reason why I did this like high-level project of projects workspace where it's doing a lot of experiments, I wanted to make a mess with those experiments. But when it comes into the actual pipeline code, I need it to be like good. So we're gonna have to redo a lot of that. That's fine. It's fine. It's good. Refactor is good. We're at a good place for a refactor, to be honest. So we're gonna look at the mess. We're gonna create a new pattern. And then we're gonna apply the pattern. Whoop. And this is a bit of a departure. We've been doing a lot of work trying to get into, trying to get into the safety stuff. And I think that's actually going to go on the back burner a bit. We're going to keep doing it. And I think we actually drove a lot of pipeline quality with the safety stuff. But, I think I need new music too. This music starts button. We drove a lot of quality with the safety stuff, but I think just it's a much bigger project than I think we have time for right now. You know, we have a runway, we have a burning cache, not a lot. We're burning a bit. And we have the ability to slow it down, and that's good. We have a lot more control than most startups like this. But I do think we have to be careful what we focus on, and I think safety is a big part of what we eventually want to do. It's a big part of our long-term offering, but I think that we need to hone it in a little bit and get back into focusing on not just engagement, but thinking through like other ways to imply engagement and imply satisfaction, to really hone in on the point of the service is to improve customer experience or guest experience overall. And safety is important, but there are other pieces in place that do that sort of thing. And I think we can bring something else to the table there. But as I mentioned, it's going to be a big project. So you'll probably see me doing a lot more sort of actually kind of fun stuff over the next few streams, over the next several streams. Really starting to work on, gestures, really starting to work on, how do we do things in real time that can actually impact scoreboard, impact the experience to make a full feedback loop, really focusing on how do we tackle privacy in real time. We have this really cool example that I was like a 1 minute quick whip up where we took the segmented versions of people, where we actually identified the pixels that are the people, and then created an outline, and then drew that outline instead of the people. And we created this like synthetic view, and I think we're gonna do more work with that. And another thing I've been really thinking about is, you know, AI is expensive. You know, I ran into this. Let me show you something I ran into. I came across today. Let me actually go over here. I think the easiest way for me to do this. Let me just grab this link. All right, we're gonna go. Is AI profitable? We'll go back to this view, you know, and we'll scroll down and you'll see, like, look at all this money everyone's making. Now, there's one company that's making lots of money, and that's NVIDIA. All these companies are burning money. And it's really interesting that Amazon's at the top of this list, because they don't seem like they're doing that much, and they seem like they would be more like NVIDIA, where they're like a supplier, but they're burning cash. They're burning cash. Everyone's burning cash. And, you know, you've got all this work now thinking about world models. You've got all this work thinking about world models and about, like, how do we get the models to be able to understand more about the world, more about what they're seeing than what they do right now. And it's just like a massive, you know, spend of tokens. So I think one of the things that actually Vi could do, and again, this is probably longer term, but I was thinking about this, and maybe we need to write something up about this. Maybe I need another checkbox and write something up that I can start to distribute. But I've been thinking about, like, what about Vi as AI optimization. And what I mean by this, you like how I crowded that all together? We can do a better job of that. We can do a better job of that. Let's go back and fix that. What I mean by that is, you ask a VLM. A VLM is like an LLM for vision. You can ask it, what do you see in this picture with language? And what do you see in this frame? What do you see in this video? And it will tell you pretty well. Optimization. Better, but still squished, but that's okay. We're not going to do it again. What do I see? What do you see in the scene, right? What do you see in the scene? And I can imagine a scenario where we take a video, especially when, you know, any video that involves people doing something, and you take the first, like, N frames, or just a small smattering of frames that help you understand what the scene is, sort of the background, right? The background. And this is how we're going to do the synthetic views as well. This is the background, right? And then we do our sort of what has become sort of more traditional computer vision, less of, like, you know, there's still a neural network involved, but it's not like these massive, you know, VLM things. And you pick out the parts that are the important parts, the things that should stand out, the people in them, what their hands are doing, what their faces are doing, what their bodies are doing. And then you supply those pieces of information to the LLM. And then you have it describe, here, what's going on? What do I need to do with this? Right? Like, how do I follow this? And I think we could probably do an experiment where we say, hey, I've done this. I've taken a few frames, done a VLM. I've taken this other data that's not LM, large model, and I've given it to a VLM, and I came up with this result, and it's a good result. And we burned this many tokens all told. between the VLM looking at a few frames and the LLM analyzing the outputs of those. And then I gave it to a VLM and just had it do the whole thing. And what do we think of in terms of like token use? Am I able to produce a meaningfully smaller amount of or you burn up a meaningfully smaller amount of tokens and still get good understanding? And does that enable new modes? Can I do more of sort of long-term analysis? Because clearly with those graphs, you're not going to be able to just like, I'm going to pass all my camera data through this massive model and have it understand what's going on, even when 90% of the time nothing's going on. Or even when stuff is going on, it's like an airport. Stuff's going on all the time. You can't just track on motion. There's still too much data. Still too much going on that you couldn't just pass it all through like a VLM kind of thing. I know there's something there. I need to cook on it. I need to cook on it a bit more. So we'll think about that. I'll put that on a Rose Thorn Bud too. All right. That way, because none of my coworkers watch the stream. I put stuff in Rose Thorn Bud sometimes that I want them to see. All right, so that's that. I've yammered on long enough about that. So let's do Rose Thorn Bud. All right. So I'm going to put under Rose. Well, I'm going to start with the Thorn. Claude VES mess. That's what we're working on today. Oh, here we go.
How about a story? Patate once yammered so long about VLMS and tokens that chat aged a full geological era. They kept saying just one more thought like it was a finite resource. And it never was. By the time they reached Rose Thorn Bud, the rose had wilted, the thorn had rusted, and the bud filed for emancipation. Anyway, they put in the notes and promised to cook on it, which is streamer for forget until next stream.
Yes. That's another thorn is I gotta fix the Twitch API sends. That's what. You gotta figure that one out. You gotta figure out how that's gonna work. Yeah, it's gonna be tricky. I'll have to come back to it. I may do some on that today because I like getting that stuff done. Roses, I like this sort of like new line of thinking that I'm kind of starting to explore. And two things. One is if we're gonna put safety on the back burner, that means we get back to more fun. Because safety, I don't know, it was feeling like a slog. Oh. I said a thing as I was getting back to fun. Doing more cool stuff with just like the actual data we have, rather than stressing out about how to get data to train a thing that like it's gonna be hard. We'll do the hard thing later. I'm into that. And then sort of new thinking. Oop. Oh my god. New thinking. I think maybe I need to make my pen size a bit smaller. It is very crayon, isn't it? All right, and then Bud, I am actually looking forward to this refactor. I'm looking forward to getting this refactor done. Okay. Let me wait. I got a text. Let me. Okay. Okay. Great. So that's Rose Thorn Bud. I'm on the right view. All right. Hey, Bobby, please take a screenshot.
Sure thing. Screenshot captured and saved to https://jplt.com's clips hot forward jetting 377 JPG also. Dyson chatbot can stop narrating now. This is an audiobook hour.
Hey, Bobby, please share the screenshot.
Ugh, yes, your majestic crayon script has been immortalized. I grabbed the screenshot and posted it in Chatros Thornbud and all. If you want in Discord too, say the word. Also, Dyson chatbots, one more thought bit painfully accurate.
Okay. That's that. Let's go here. Let's go here. And let's check this off the list. Use red. Check. Let's check it off that list. All right. So now we can put this aside for a little bit. All right. Okay. Oh, I didn't put that in Rose Thorn Bud like I said I was going to. That's okay. I'll talk about it on Friday. We have a meeting on Fridays to talk about it. Why would you... Why does it do that? That's really annoying. All right, you go away. All right.
My eyes, the goggles do nothing.
Yes. Okay, so let's start with the very top level, pipeline. And let's look at what happened here, because it's kind of bad. I'm gonna make it bigger. Make it bigger so we can all see. We can all see what he did. You know what you did. I'm gonna hide that one. All right, there we go. All right, so we've got a lot of this action where these are stages of the pipeline. You know, associate faces, config loader, crop faces. And each one of these is a separate, oh my God, they're all separate functions. They're all just imported into this one namespace. Oh my goodness gracious. So that's the first thing. You got to figure out what is the common pieces of each pipeline stage. Each stage, we need like a generic stage class that we can inherit from. And then each one of these sort of stages needs a specific implementation. That's the first thing we're going to do. The other thing we got to do, and that might not actually be the right order because there's also this mess. Normalized stages. Now this, I understand why this needs to be in here. Normally, if I was writing this code, if you specified nonsensical stages, I would just let it crash. I would be like, well, don't do that. You know? So, you know, I get this is probably better. You know, it should figure it out and say like, well, this doesn't make sense. But it is a long mess. And then we haven't even gotten to the worst part yet, guys. Oh my God. Here's run pipeline. This goes from line 250 to 471. It is like 200 lines, just straight function with these like giant ifs. Oh my gosh. Terrible. Terrible. So we got a lot of cleaning up to do. We got a lot to do here. That's okay. We're going to do it. We might not do it all in one stream. We probably won't. I'll probably run out of steam, but we'll do what we can. Okay? All right, so let's start. All right. So the first thing I think I want to do is, you know, we've got this load config source config loader, load config. Let's take a look at this config loader. And I think one of the things it did do a pretty good job of, although I'm sure it's a long string mess, is, on the wrong thing. No, you go back. You're good. You did a good job there. This, I didn't do a good job. Config loader. So it did do a good job of creating these like data classes that hold on to all the parts of the config. So it's all well defined. It's not just like load this thing into a thing. That I like. Merge config, loading config, class config. Here's all the parts of the config. What is this method field? Find def field. Oh, it is like a built-in thing, huh? It's from, oh, okay. I don't use data classes, so this is new to me. Okay, so that's fine. I like that. You go away. Load config YAML and return a config data class. YAML safe load or empty. Okay. And it returns this. Returns a config object. I see. Okay. This one's actually reasonable. I think what I would do to change this, if this was me, if I had written this from scratch, I think I would have a config class with a load method. And the load method would just populate the rest of the config. And then I would pass that around. I would have, first of all, my top level pipeline would be a class. That has been the pattern I've used for a long time. And I thought even when I started this, I said, in fact, I know I did. I said, use the pattern in this. I have this like, GitHub repo that is like, this is my Python pattern. This is my Python. Why is my brain not braining? Now I gotta go see. I gotta reload this thing into my brain. Boilerplate. Oh my god, boilerplate. I have a boilerplate. Okay. And look at this. This is the other thing I don't like. I really, really don't like these data class. Okay. So this is okay. I really don't like passing in all this stuff. All right. So here's what we're going to do. We're going to change this. This needs to be renamed. I think it's going to be called, all these are like sub configs, right? Because I want to use this name. I want to use the name config. So this is going to be called full config. Okay. And then we're going to have a class called config. And that class is going to have a load. And it will also hold on to the full config. Okay. So we're going to do down here, class config. No. It's going to take a path. Listen, you gotta stop helping me. Okay? You're driving me crazy. And I'm going to do, I haven't been doing this. Have not been doing this like, no, nobody said that. Nobody said that. Listen, you stop. Stop. Don't help me right now, okay? I'm doing this. Oh, you know what? I know what's wrong. Okay, so we need this. See, this is why you're driving me crazy. Def. In it. There. That's what I need. Oh my God. All right. Now we're going to have self. Equals self load path. Okay. No, I didn't say that. I didn't say do that. This one. It's gonna move. Cut this down here. Okay. There you go. Now here's a part where you could be smart. You want to help me figure out that that's what I want. That's not what I want. That's what I want. Okay? Okay. Now, here is going to be the problem, right? Uh-oh.
I remember a quote about figure. It's not enough to guess, you have to figure out what you actually want. Then make the code do that.
Okay. Interesting. What am I doing next? Okay, yes. So here's what the problem is. So now when I want to use this config, I bet you this config is used all over the place. It's passed around like, you know, a football, I guess. Passed around like a joint or something. I don't know. All right, it's passed around a lot. The problem is going to be all of these things want to just use it, right? They want to just like get these things. So what I need to go and look at, let's go back to pipeline. This is not going to be config loader. This is going to be called config now. So this is going to be renamed config.py. Oh man, I'm going to break this thing so hard. It's going to be great. This thing's, oh, and you know what? You know what? This is in a weird branch. Okay, well, it's too late now. It's in a weird branch. We're going to have to merge it. That's okay. Should have done some housekeeping first. That's okay. We're going to do it this way. We're doing it live. All right, so config loader, load config. All right, so load config, right? And then it just like accesses these things, right? Okay. So now what I want to do is I want to def, yep. I don't want you to auto load, but I do want you to get at her, right? And what it's going to return is not an any, it's going to return a data class. Data class like that? No. Oh, I see. Data class is not. I see. Okay. It's okay. So let's do any. Any's fine. Data class is a decorator. It is not a type. Okay. So here, if config is none, we're going to throw an error. We're going to raise config is not loaded. Okay. 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 I think that's good enough. And we could go a step further and check to see if whatever's in config is a data class something, but I don't think it matters that much. I don't think it matters that much. So this is good. Okay.
It's interesting you mention matters. It matters when silent failures cost you later ID at a typing.protocolconfig type assert config is not none, with a clear exception. Also, data classness rarely matters interface does. Joke my config matters until it meets production.
That's another thing we need to work on at some point. All right, so now config becomes, so now, oh God, nope, don't do that. All right. Up here. Now, and we're gonna start moving these up from source config, import config. Nope, not load config. There is no load config. Okay? Get that out of your mind. Okay? Config equals config args config. Config.load. Okay? Boom. That is the first thing that we have to stop. Oh my God. All right. I already feel better about it. That's it for no. That's all the code I'm going to do today. All right. So the next thing that we need to do, I think we should go by the stages in the pipeline in order. So from source detect, we've got detect persons from tiles, load detections from disk, load the model, save detections to disk. And it's just detect, which I don't like. I hate that. So in here in detect, we're going to take a look at this. Oh my God. So there's going to be a lot of this problem. It's okay. We're going to get there. All right. So we've got load model. We've got infer. This runs the model. We've got detect persons. We got non-maximum suppression to merge overlapping detections. Okay. Detect persons from tiles. You run yellow on tiles. Okay. Okay. Save detections to disk. Load detections from disk. Okay. Not too bad. Okay. So now, we need a generic stage. We need a generic stage. And an understage is going to be a bunch of stages. Does that make sense, right? Yeah. Or we could even like do it like the real module Pythonic way of like init is the base class and then the rest is under that. Maybe should we do it like that? I don't normally, I almost never do underscore stuff. I almost always leave init alone. I just leave it blank. And I'm going to do that here too. I'm going to leave it blank because that's what I would do. Okay, so we're going to have stages. And then we're going to have under the top level, we're going to have a new file, stage.py. Okay, stage. And in stage, we are going to class stage. And we're going to def init. Yep. Now, one of the patterns that I do, and I don't think this is a pattern people will like. I think if programmer friends saw this pattern, it would be like, that is gross. But I like this pattern, which is I pass into the constructor a parent. And the parent has stuff like the config, the logs, the args. And I copy those references, and then I don't do anything with parent anymore. So it doesn't create circular reference kind of stuff. But I also don't have to explicitly say, I want the config and the log and the thing and this other thing, and oh, I forgot a thing and I gotta go back. Just give me the parent. I will copy what I need from the parent, and we'll move on with our lives. So that's what we're gonna do here. Okay. So parent is an any. We're gonna go ahead and continue using these any like that. Any like that. Okay. So we're not gonna self-parent. No, we're not. No. We're gonna say self config equal parent config. Yes. Yes. Correct. Now, what are we doing for logging? Because I don't even know. I gotta go back. I gotta go back and see. What are we doing for logging, friend? Logger logging. Okay. So that's gonna have to be fixed too. I swear to God, I told you I wanted you to follow my thing, my boilerplate, and you didn't. You just straight up did not, and I don't appreciate it. I don't appreciate that. Do we have, so we have config YAML. I don't think we have secrets. Don't think there are any secrets in here, to be honest. Here's what we're going to do, though, because I don't know. And I can't put this on the stream. So what we're going to do is go here. What about this? Look at me. Look at me. Look at me. Look at me now. I'm going to go through here. I'm going to quickly scroll through here for anything that looks secret. I'm pretty sure it's not. There's no secrets in here. I mean, if there were secrets, we'd be in trouble because it's definitely in source control. Okay, there's no secrets. Right, we're good. All right, we're good. It's fine. Okay. So then, I think all we're gonna need, because pretty much everything is done through config. I don't think there's anything done through args that wouldn't be top level. Wouldn't be top level. So I think this will be all we need for stage. And then inside stage, there's going to be a few things. Now, a stage is going to need thinking here for a second. I gotta think here for a second. So stages, let's write out some stuff here. Let's write out some stuff in comments. Who's Justin Lee? All right. No. All right. So a stage. Stage takes input from a prior stage, or oh yeah, it could take a potentially takes input from one or more prior stages. This input can be in memory or on disk. The stage produces output that is either in memory or on disk. Now, I kind of feel like we could make this a pipeline that is where one thing feeds into another. But there are times where one thing, an output of one stage, will be needed by a bunch of different ones. And I almost kind of feel like rather than having, you know, return this, keep it in memory, make sure it passes to this other thing and all this kind of stuff, I kind of feel like there's just this needs to be this one object, like a singleton class that is here is what I've produced so far. And in that is references to every stage that has run, the outputs of that stage, whether or not those are in memory or on disk, and how to get them. And you can just get that. And if you have what you need, you do what you need, you put it back in there. And then we move to the next stage, right? And that makes it so there's just this this is everything that we've worked on so far. And then it will go out to, we'll decide at the end what to persist, right? That is, I think, how I want to do it. Because it feels like I've been doing a lot of this hand-wringing about stage order and, is this going to take the faces or the people, or does it need both? And I don't want to do that anymore. I just want, as we're developing, if we decide a stage, we could use other pieces of information. Great. It's already in there. If that stage is already run, we have it. Use it. Do you need the original frame? Great. It's still in there. Use it. And then I think kind of what I'm going to do also is just make a decision that pixels are always persisted to disk. And the reason for that is if I don't do it, then I'm writing caching. Because I can't guarantee I'm going to always keep all the pixels in memory, right? Especially if I'm going to run this a bunch in parallel on a machine.
I remember a joke about caching.
Okay,
there are only two hard problems in computer science cache and validation: naming things and off-B1 errors. Yeah, I know. It's literally a caching joke that forgot how to count.
No, that's not what that joke is. That's an off by one joke. See, this is why we can't trust Claude to write code for us. We got more oversight. Okay. So again, we're going to have sort of I don't know what I'm going to call it, results. So that makes the stages really easy too, because then the stages are just give me the, and then I got to think about this. Maybe I follow the parent pattern. Maybe I follow the parent pattern rather than make a singleton. Because effectively the config and log are either the parent pattern, or pass it in pattern. It's, you're only going to have one instance of config, one instance of log. So I could just make those singletons too, but then it starts to feel like global variables and all this kind of stuff. So I think I'm going to follow the parent pattern. So what that means is that we're going to have something, I don't know what I'm going to call it. Should we call it a data set? Process set? So let me describe it again, and then I'm going to ask for some help from one of our two host streamers. So this will be the outputs of each stage as we're progressing through the pipeline. We need a name for whatever that data structure is. That data structure will be passed by reference to each pipeline stage. And each pipeline stage will be able to do with it as it will. understand, use any inputs it wants, and then add back into it the results of its output. What do I call that, Bobby? Bobby, what do I call that?
Call it a context or pipeline context. It's the shared blob every stage reads writes. Results is vague, dataset lies. Also, we tried bag of stuff on cepitate, oh no, hated it, and I lived another day.
Yeah, I like context. Context could work. Okay, we'll call it context. Okay. Done. Okay. What's interesting about this too is that now we can take the responsibility of persisting to disk for debugging purposes out of the stage by stage process. We can just say, hey, persist the context at each stage, or persist the new pieces of context at each stage, and the context can do it itself. Which I like that too. It makes the stages dumber. All the stage needs to know how to do is like the actual processing, right? All right. So now that means we're going to have a validate context portion, right? This makes sure that what we got is what we need. Okay? Right? Now I need to think about I guess it'll be the context responsibility for all right, I'm thinking. This is going to need a name. Sturt. Yep. You're going to need a name. So listen, guys. You're trying to help me too much. I need you to just relax. Relax. Oh. Okay. Need you to chill. Let me type. Oh my God. Yikes. All right. I think the next thing I'm going to need to do is actually shift gears and start defining the context. Because what I want to be able to do is have run produce a an object of type like context part or context thing, like a subcontext, right? Let's just say we're going to say pass. Yeah. Yeah. Because then Let's start with this. Let's go back to context. So under here, we need a new file, context.py. Okay. What does this thing do? Yes. It is responsible for persisting data to disk if needed, loading persisted data from disk if needed, I'm going to say persisting pixel data to disk in all cases. Loading pixel data from disk on demand when Sage needs it. Persisting data to disk for debugging non-pixel data. Or resuming from a stage. No, not that way. So I think I'm going to follow that sort of data class pattern, right? I don't want to learn more about what data class decorator. What's the best way for me to do that? No, I'm just going to the old school way. Python data class decorator. What is this thing? Data classes. All right. Let's read some actual documentation. Oh my god. I see. Okay. Is there inheritance? Something just popped. Something just popped in here. I don't know what happened. All right, so Python data class decorator inheritance. How does that work? Python data. What are you gonna say? Okay. 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 So then we are going to I think we're going to have strongly typed data classes for the actual outputs, but we are not going to have strongly typed data classes for context overall. That's going to be loose. So that way we can add remove stages. And we don't have to go back and like create the canonical list of all stages. Each stage can define its data class that contributes to the overall context, but context doesn't really need to know about that. It's just going to have a list of these things. So kind of like how in config in here, we've got this full config. And this full config is just basically a bunch of other configs, right? We've got this. But rather than me having to define all these, and I may actually go change that in this too. I think for config, it's okay to have it be more rigid. But for, well, I mean, I'm actually kind of arguing against myself there, aren't I? All right. We are going to have like a, should we call it subcontext? I mean, I guess we could. Subcontext. This is a data class, right? We got to import data class. All right. Yes. Okay. Do it. Right. And then this is going to have the name of the stage, right? Gonna have like some generic things. I want to have some like performance characteristics in here. I could, let's not overthink this. Let's not try to account for everything. Let's just do the basics. Okay, so it's just gonna have a name. It's gonna have not a data. Why are these? Why are these are not supposed to be commas? It's just supposed to be like that. Okay. I kind of want a status.
There's a quote about status. Status is just yesterday's headline, show me your habits, and it'll show you your future.
I don't want this as a dict because we're going to define a data class for each one of these. So would this just be an object? Yeah, okay. And then each stage will define a data class that overrides this subcontext with Actually, I think it'll just override results, right? That for the data it produces, which will be stored in results. Yes. Now we still need to think about how this is going to work with pixels. Come back to it. We'll come back to it. All right. Okay. So now let's do it like this. Def start stage self name string. Okay. Yep. Import time. From time import time. From time import time. This time. Why are you red? What's wrong with you? Okay. And this is too long. I don't like that. I don't like that. I don't like that. Boom. I want it to be like that. Okay. Okay. And we can add like fail stage and stuff like that. and reject and all kind of stuff. Okay, all right. Now, this doesn't handle the persistence piece. We haven't done the persistence piece yet. Okay, so let's actually go now back to pipeline. Okay, I'm going to look at the first part of this. I'm pretty sure the first part of this is. Oh God, we got so much work to do, guys. Oh my God, it's okay. Extract frames async. This is what I want to take a look at. Let me get back frames. Frame data. Let me get back frame data. I guess it kind of does make sense, actually. I guess it kind of does make sense, actually. To have, because you know, especially like in this part, like FFmpeg, right? We are shelling out to a thing and saying, make these frames. And it's writing those frames to disk. So if we wanted context to be responsible for the disk persistence, we'd have to do something very ugly where we load the frames, put them in the thing, and then have it persist the frames back out. That seems dumb. That seems very dumb. Although, that's precisely what's happening right here. Uh-oh. Uh-oh, there's a big yawn, you guys. Oh my God. Wait. Oh no. This is exactly what it does. It extracts the frames, right? Yeah, pipe. Opens it up as a pipe. Okay. Well, then maybe I take that back, because if that's how it's going to do it. I mean, the advantage of that is in real-time mode, we could say we never touched this. All right. This yields frame data, image, MP from buffer. So what is this? This is an ND array. Okay. And I bet you everywhere because this is all like, yeah, CD2. Yeah. So I bet you everywhere we're doing anything with pixels, it is ND data. So here's what we're going to ask. Do not edit. Okay, I'm working on a refactor of this code. I'll be writing the refactor myself, but I could use help with a quick analysis check. Everywhere where we're using pixel data, everywhere where we have pixel data in memory, is it in a candy array type? All right, yes. All right, I'm gonna be right back. I'm gonna get some more coffee. Get coffee. And stretch my legs a little bit. And then get back to this. All right, so, hey, Dyson, please start a break. Terrible. Come on, buddy. You can do it. He's not gonna do it. He's stuck. Hey, Bobby, please start a break. Oh, man. Got a big mess going. All right. You know what? I can do it myself.
There's something very fascinating about timekeeping contraptions. I've made quite a few myself, but I have to admit I have great trouble making them very reliable. And when I actually need to know the time, I look for the nearest quartz watch. It's easy to forget just how clever these little things are, particularly because you hardly ever need to do anything to them. And they're so accurate, they rarely need setting. So in this program, Rex and I are going to rescue them from obscurity and look at their history and how they work. The earliest timekeeping device was simply a stick in the ground. The ancient Egyptians measured the angles of the shadows it cast, and the Greeks measured their length. This may seem rather crude, but people didn't usually need to know the time very accurately. It was usually quite good enough just to have some idea how much daylight was left. And the stick does have the enormous advantage, like the quartz watch in fact, that it never needs setting. The Greeks and Romans also had water clocks, but these were mostly just bowls with a hole in.
Clock started.
They were used as timers for rationing irrigation water.
That's it. Time's up. Oh, what's my campus is hardly dampus.
They were also used in the courts for timing the speeches. Unscrupulous senators are said to have gone to great lengths to make their opponents thirsty to shorten the speeches.
Et in ordine quisque agua. Oh!
The first people to attach any great importance to accurate timekeeping were the medieval monks. They had up to 9 services a day, and it was considered vital to hold them at precisely regular intervals. At first, these intervals were set by water clocks, But at some point in the late 13th century, the first mechanical clocks appeared. Initially, they didn't bother with dials. The important part was the bell, which summoned the brethren to prayer. Our word clock comes from the French cloche, meaning bell. This particular clock is one of the oldest still working in a church. It's about 400 years old. Although it obviously doesn't look at all like a quartz watch, the principles on which it works are really remarkably similar. If I take a quartz watch to bits, you can see there are basically four parts inside. There's the splay, the battery, the silicon chip, which is under this blob of plastic, and this little tin can that contains the actual quartz crystal. It's actually a lot easier to understand how one of these things works by looking at the clock in a bit more detail first. The display is obviously doing the same thing as the dial on the clock, and the battery powering the watch is doing the same thing as the weights in the clock tower, but also the crystal is actually providing a regular beat in very much the same way as the swings of the pendulum, and the silicon chip is controlling the whole thing, just like the gearing. The heart of the gearing mechanism is the escapement, which interacts with the pendulum. It pushes the pendulum to keep it swinging. At the same time, the escapement is held back by the pendulum, regulating the clock's speed. The properties of the pendulum were discovered by Galileo in 1590. To mask the pong of the peasant congregation, the priests used a swinging censer to fill the church with incense. Galileo realized that the censer was taking exactly the same time to swing from side to side, however far out it went. He had trained as a doctor and used his pulse to time the swings. Galileo was in need of an accurate clock for some of his astronomy observations, so he simply set up a swinging weight in his observatory and paid a man to count its swings all the time.
Le stelle stasera sono meravigliose. Bellissime, bellissime. Ma cosa fai?
The solution to this problem was to fit the pendulum to a mechanical clock, and this has remained the basis of clockwork ever since.
This is the escapement wheel and pendulum of a water clock I'm building for Felixstowe town. The water acts like the weight on the church clock, pushing the escapement wheel round. The escapement interacts with the pendulum in the same way. No matter how far the pendulum swings, it always takes the same time. The only way to alter it is to raise or lower the weight.
It's not obvious how a lump of quartz could possibly do the same thing as a pendulum, but it really is quite similar. The quartz does move. This is a bit of crystalline material similar to quartz, sandwiched between two bits of metal. And if I connect this up, I think you should be able to see it move. The electricity is making the quartz distort. This was discovered by Pierre and Marie Curie in the 1880s and called the piezoelectric effect. In the watch, it's used to make the crystal vibrate. Here I've cut the crystal out of its tin can, and under a magnifying glass, I think you can see it's cut in the shape of a tiny tuning fork.
I don't remember this one.
It vibrates in exactly the same way as an actual tuning fork. These vibrations have a stable, natural frequency, just like the swings of the pendulum, though in the quartz crystal, the movement's much too small and fast to be visible. The piezoelectric effect also works in reverse. So if I distort this cylinder of crystalline material, by squashing it, it actually creates some electricity.
Whoa.
This is actually the crystal out of a piezoelectric gas lighter.
That's pretty cool. All right, here we go. All right, what did you say? Okay. Thinking now. I think what I need to do now is try to define a stage. Work through where it breaks down. Add those methods. And then go from there. So we're going to start with this first frames stage. Right? So in here we're going to go new file. I'm going to call this frames. In pipeline, this is actually defined as frames, right? Frames. Try to keep the names the same. Okay. Import stage from stage. Does that work like that? Does that work like that? No, it does not. Oh, wait. From is it dot stage, import stage? Is that going to work? Or is it dot? Oh, that's what I need. Okay. And we need def, init, self, parent, and yep, that's exactly what we need. In here, we're going to, so ffmpeg IO, they do define, it does define a thing. Frame data, where's this? frame data. Oh, and this is in schemas. Oh. A lot of this is already done. I actually don't need to import context because I already got context. Okay, so now FFmpeg.io. This takes video frame, video path, config, which we have, video info, right? We don't have, but we can get it. That's built in here. Okay, this is going to be an async IO. Okay? All right, this is going to come together. Import async IO. Okay. So one of the things we need to do, actually, see, it's already starting to make more sense. So this is also going to be import async IO, right? And this is going to be an async thing, right? Frames, right? So this is an async thing. Okay. Okay, so self context start stage. Haha. Okay. Actually, now I'm starting to think that each stage needs to be able to persist its own piece rather than having the other thing be able to do it. We're going to think about that. We got to think about that. It's going to be tricky. All right, well, let's keep going. All right, so we start stage. Very good. In FFmpeg.io, we've got probe video. So that's not true. We do have a context issue in that we need the original path. That's going to be the first thing. Frames stage will need context for, we'll need start context, which will contain the video path and any other associated So in schemas, let's create a data class. Data class start data. We're just gonna have video path. I'm not gonna have frame rate because I don't think that's useful. We can come back to it. We can come back to it. No. Sorry, I'm thinking. I'm thinking. Okay. Okay. All right. So now, let's go back to this. We count frames, probe video. Let's just take these things. Although I may refactor. I mean, some of these are kind of long. Stop it. Oh, God. You're helping me too much. I don't want this much help. Okay. No. Stop being a dick. Okay. I think everything in here looks good now. Okay. So that's that. Oh my God, this is so long. I do not like when methods are too long. Do not like it. old video, and it's just going to take self. Okay? And then path is equal to, okay? What? No. Stop it. Autocomplete, please. I'm gonna turn it off. I swear to God. Okay. No. Stop being a dick. Oh my God. All right. That's going to come out. We're going to say async def extract stream info self dict. Do not extracts this video stream metadata info. Okay. All right. Now this is stream equals. Okay. Now this part. Oh, this thing needs data. Well, then you're going to return data and not stream. Please stop doing stuff like this, okay? Thank you. Just leave it alone. Fucking Christ. All right. All right, so which of these things? All right, so I want to break the. I want to put this somewhere else. There's a bunch of stuff in here it doesn't even need, right? Like doing all this stuff. Oh, for cross-checking only. All right. All right, what do we need? What do we need? We need our frame rate, our kind of wanted to like make this into just like a handful of things. Stop it, stop it, stop it. Okay, get video metadata. Get true frame count. Calculate additional metadata. And that's all this stuff, right? Huh? So all this can be in another thing. In fact, the way we can do this, watch this. All right. Extract video info, count frames, calculate metadata, counted frames, and this is going to be result equals that. No. And this is going to be def. Calculate. That's all this stuff. And the way, you know what we're gonna do is, here's what we're gonna do. I know what we're gonna do. Part of the validate context is going to be self path equals that. Now, everywhere we're doing path, we can just say self path. Stop it. Dumb shit. Suck a dick, dumb shit. All right. That. Yep. 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 Get out of here. Yep. Yep. All right. And even this feels like it's too long, to be honest. Like, really want to get back into a method that does exactly one thing, but it might be tough. right. I think it's okay because this all is like metadata calculation stuff. So it's not too bad, even though its method is like almost 60 lines. Okay. So that's count. We got count frames. We got probe video. And then this actually needs to move up. We also want to keep things in order. That returns that. That gets that result. Return result. Now probe video is very clean. And this actually goes in here. What happened there? You, dude, don't be a dick. All right, you know what? Oh, no, you go back. All right, you, fine. Now you go here. Okay. Okay, so now that raises, this becomes even more simple. Okay, truly just those things. Okay. And in fact, we don't even need this in here. It's just the data. Oh, stop, please. Please, everyone just stop. Getting frustrated by the... Stop. Stream. Okay. God bless America, dude. All right, so that's the first part of that. It's gonna take a long time. It's okay. Now we have, this is where the actual running happens. Okay, so we're gonna take this. All right. And this is where we're gonna start to get into like the persisting question. Please, okay? Please. I was all the way up here. Okay, look. All right, hang on a second. You recommended a change down here, and I went up here, and I hit tab, and you thought what I meant was scroll all the way back down here and accept your change. Okay. Okay, bud. All right. So we don't need that. We don't need that. We don't need that. We don't need that. This all needs to get indented. Okay, nope. Everyone can chill. Everyone can just chill the beans. I know I need a thing. Okay, don't. That's another thing that's annoying. and there's probably a real reason for this, but like, why do these things like importing things in the middle? That's never good. That's never something anyone wants. That's not what you want. All right. Whew. So now, this thing is going to say, probe the video. Okay. Extract frames async. Is there ever a time where it comes in? I don't think so. I don't think so. All right, so now this can be self-config. Yes, yes, yes. Why are these things in config? So this is something that's gonna have to get fixed. So I bet what's happening is in argument parsing, it's jamming these things into config. And these things actually need to go into the context. Good Lord. But we can come back. So let's put a to-do here. To-do, move these arguments into context. Okay. This is self.path. Yes, yes. Okay. All right, so we need NP. We need MP. Okay. NP from Dumpy. There you go. There's that. Boom. All right. Okay, we're yielding. We're yielding.
There's a story about arguments. Once Pod8 tried to temporarily stuff CLI args into config, and I, Bobby,
wasn't me,
watched it become permanent in 0.3 seconds. Next thing you know, import spawn midfile, context is empty, and everything's self.config forever. Moral args go to context config stays boring. Also, I lost the tab fight.
Now this thing yields frame data. This needs to be a private guy. So watch. In pipeline, I think it's done in pipeline, right? This is all part of pipeline. All right. Extract frame data. Yeah. So okay. Interesting. What does load frames from disk look like? This is also an async generator. Save. Okay. So because this is an async generator, and we're yielding, right? So that means other things that are iterating over that are only taking the one thing at a time, right? Okay. Okay. So at most we have one frame in memory, right? It's actually not too bad. I mean, it's a 4K frame, but it's actually not too bad. But then, you know, from that we create a bunch of crops, we create a bunch of other stuff. But honestly, like, I can't parallelize this thing so much. I don't think, actually, because this thing loads a bunch of models, those models can't really be parallelized. Like, if I want to use the model, actually, I don't know if that's true. It's what I've been doing. Let's see. I'm going to ask a question. Let's ask a question. I'm pretty sure this is the case, though. I'm going to ask a question, though. Yeah. Oh, now Fable's in here. I can slash model it. Let's see. Nope. Switch anytime. Included with my plan. Slash model. Fable. Let's just type slash model. No, it's not in here. Goddamn liar. I might need to reload. Anyway, we'll come back to it. Okay. This is a general okay. General question about using models like YOLO in parallel. If I'm running multiple processes in parallel, working on separate videos / files, do I need to load YOLO once for each of them, or is there a way for the GPU to share that memory? Pretty sure I know the answer to this, but just want to make sure. Oh man, we're at 2 hours. Look at that. It's flying by. It is flying by. Okay, here we go. You don't need to listen, I just need a quick answer. Separate OS processes do not share model weights in VRAM. Each process gets its own CUDA context and its own copy of the weights. There's no automatic GPU side deduplication. So, what's actually using VRAM? The weights. So you could theoretically do that. Okay. Oh, CUDA multiprocess service. Oh, okay. Well, that doesn't really help me. All right. All right. Well, that's good to think about. I'll come back to it though. Okay, where was I? Right. Okay. So you go back away. I don't want to look at you anymore. All right. Back in here in frames. Okay, so now we've got run. So in this case, run is going to be async generator frame data, right? Okay, okay. And then, so then back in pipeline, no, back in stages, we're going to have in stage, we're going to have async def persist self and async def load, right? And this is going to be an async generator. Yep. And we need what was that? What was that from? This from typing. Okay. So that's an async generator with something. And so is this. There's a problem. There is a problem with this method. Rethink this. So, if we're using async generators, right? And more than one stage of the pipeline needs the same data. And the async generator is like sort of, running in time to produce the data for the pieces of the pipeline that need that data. Then either we need to make sure that those parts of the pipeline are all kind of running in parallel, and somehow they're all getting the same yields, which I don't know how I would do that. Or we have a problem. Okay. Let's save this here, and then we need to ask some questions. In my refactor of this model, I have a base class for stage for each stage. I also have base class stage for each stage. I also have a context class where the stages can put their outputs. The reference to this context is given to each stage, so each one can independently, oh my god, validate that the context contains what it needs and produce new data to add to the quotes pile. Add to context. Just say add to context. I think I have a gotcha though. The pipeline is generally a sync generator based, and there are multiple parts of the pipeline that depend on the same pieces of data. That is, for base detection, we can require person crops or not, and for pose, we also need those person crops. How can multiple stages of the pipeline receive the same yields? The person crop generator. Does it have to run? Let's just start with that. You're gonna say dumb shit because I'm in the middle of doing this refactoring. It doesn't make sense. It's like this, you're fine. Oh, we gotta check some boxes while we're waiting.
Well, we're waiting.
It should say that automatically every time Claude goes off and does a bunch of shit. Well. Okay. I think we're almost to create a pattern. We're going to put a line here. We don't know yet. Dude, stop. I'm in the refactor. Stop reading all this old shit. All right. An async generator is single consumer. If detect faces and detect pose both async 4 over the same crop people generator, they don't each get every crop. They steal items from each other. Whoever's scheduled next pulls the next yield. There's no built-in duplication. So how do multiple stages receive the same yields has no answer at the generator level. Generators are for streaming within a stage, not for fan out cross stage. The thing you fan out from is the context, not the generator. And your context is already designed for exactly this. It's doc stream that says a persisting pixel data with this, loading the pixel data with this. Okay. If a particular fan out is hot enough that a disk round trip hurts, Then one producer task that pumps each item into n-bounded queries, one per consumer. All right. All right. Let me think about this a little bit more then. We gotta draw some pictures. I think we gotta draw some pictures. So we're gonna go here. Picture time. All right. Page. Oh, I got a lot of pages. All right. We have a video. Oops. That's video V. And it produces frames. Right? And then each of these frames produces more stuff. This produces people. And this produces, each of these produces faces. This produces faces. And this produces emotion. Right? And each of these, like, it fans out, right? But we're only... It's not like we extract all the frames and then extract all the people and then extract all the faces and then extract all the emotions. We're doing this as we go. Okay? So each stage of the pipeline, I think what we actually need is sort of an event-based system. I think we need an event-based system. So, and let me go back to what you said here. In-memory async broadcast T, only if you must avoid. In some cases, I need to avoid it. So if I'm going to ever do real time, I'm going to need to avoid it. All right, I'm going to ask some more questions. Because one thing is true, I think. At each stage, Each stage is dependent on stuff before it. So, for example, for every emotion, there's only one video. For every face, there's only one person. Well, unless they can be independent, but there's only one frame. For every frame, there's only one video. Right? I think we can do this like context is frame, because at the end of a frame, context effectively resets. This is context. And actually, each part of the tree does the same thing, right? Because at the end of a person, when we're done dealing with the person, we're moving on to the next person. Everything under person effectively resets. Let's put this in this mode. Okay. All right. Don't ask me to do stuff. Okay, so I want to ask you some more questions. I want to ask you some more questions. Please don't. Have a potential design pattern I want to run by you. I don't need help with implementation yet. I just want to get a reaction. The pipeline is effectively producing a tree. Each video has n frames, which has I frames, which has j people, which have k faces, which have where some parts of the tree are one-to-one, person to pose, person to face, person to emotion. But it's still effectively the same structure. When the pipeline is done with a particular piece of the tree, the entire thing, everything under it is no longer needed. We don't process frames. We never look at a frame again once we've moved on. people and faces. We can build context to be more like an event bus. Each stage of the pipeline is waiting for events that are relevant to them. If face detection is configured to require person crops, then it waits for the person crop generation, person crop event. Similarly, the pose estimation stage waits for person crops. Context will contain the entire entire current branch. So one frame, one person crop, one face crop, etc. Moving to the next person. Moving to the next. Iterating to the next. Face resets that part of the tree, iterating to the next person. Face, person, frame, etc. Resets that part of the tree. What are some pros and cons of this approach? Where will it break down? I think this is an example of like when you know your data, you can do much more with it. Like when people are trying to optimize their database for the first time and they're really struggling with it, I talk about how databases are correct first and fast second. But if you know your data, then you can make decisions and make the database go fast. I think that's effectively what we're doing here. Yes, we could persist everything to disk, but because I know my data is tree-like in nature, I can probably get away with not doing that, even in the case of massively parallel systems. And in fact, if I get into the point where I'm loading the models and I have like an efficient way to pass to the models through an IPC kind of mechanism, then we could get into some really cool stuff. Okay. Oh my God, it's a lot. You talk too much, guy. You talk too much. Good pattern to be, and the instinct is right, pub sub naturally multicasts, so it dissolves the fan out problem from your previous question for free, but I think the model is fusing two separable ideas, one of which is great, one of which will fight your actual pipeline. Let me pull them apart. All right. The event bus routing is the right stage. Stages subscribe to the events they need. One person crop event reaches both the face detect and pose is exactly the decoupling you want. Adding a new consumer of person crops becomes add a subscriber, not rewire the generator. That half I'd keep regardless. Memory bounded by depth, not breadth, is real and valuable for a pixel-heavy pipeline. You already push pixels to disk specifically to manage RAM. I don't want to over-index on this decision that you made a long time ago, which I don't think is correct. Done with the structure is the clean, and the cleanup is implicit. For the strictly hierarchical, stateless one-to-one hops, person, pose, face, emotion, person, face, this model is close to perfect. Okay. Your computation isn't a pure tree. The proposal's load-varying assumptions, it's a tree. We never look at the frame once we move on. Both are false. Okay. Concretely, against your own stages, cross-frame face detecting X002 is the headline shift feature and is defined by looking back at clusters, FaceNet embeddings across frames to assign a stable track ID. Okay. All right. We can have a window then. Slightly wrong. Yeah. Batching dies. GPU throughput on. Wait. I don't understand this part. Wait. I don't understand this part. Where else it breaks down. GPU throughput on YOLO, MediaPipe, FaceNet, the emotion model, lives on batches. Yes, you are right about that. You're right about that. Okay. Pipeline parallelism dies. Your async generators let frame ends faces run emotions while frame in +1 is still in person detection. Okay. Yep. Make the reset unit the full frame. I agree. Okay. Yep. Okay. So if we make the tree reset only at the frame level. And we have a configurable number of frames that we... All right, what? Wait, first. Look, I don't want to over-index on some of the prior decision making about persistence and stage independence. Ultimately, we want to move closer to real time. So, thinking through how we can adopt memory more disk optionality is important. So, I think your suggestion to make the tree reset only at frame level is a good one. We can maintain a configurable number of frames to keep in memory of frame trees to keep in memory for cross-frame tracking purposes. We can also drop the actual pixels of the frame, the full frame. Once person and face detection complete. We can have a kind of dependency chain that we can use to manage the memory a bit. Batching question is an interesting problem. Are the existing consumers of the async generators just collecting yields until it reaches a batch size and then deploying to the model? Right, we're getting somewhere. All right, this is actually kind of fun. We're gonna get to a much better. Again, we're improving our pipeline significantly. This is gonna be so much nicer when it's done. This is gonna be one of those things I'm gonna like really. It's super like focused on, I guess. Almost at 3 hours for the stream too. Pretty good. Getting better at this. All right, what do you got? All right. I like this much better too. All right. Confirmed, and the answer sharpens your design because batching turns out to be another horizontal edge just at a different granularity. Direct answer. 2 of them batch, the pattern is accumulate and flush. Exactly what you described. But the axis each one batches on is the important part, and they're not the same. Detect persons, whole frames, at least end frames. Detect persons from tiles, tiles of one frame's tiles. Oh. Huh. Interesting. Well, no wonder this is so much faster. All right. Detect faces from person crops. Nothing. 1 crop at a time. Unbatched. A latent throughput bug. Yep. Classify motions and faces from anywhere. Okay. You now have 3 different breadth requirements layered on the same tree, and they don't share granularity. Well, doesn't that happen automatically with garbage collection? Okay. Doesn't ref count happen automatically with Python garbage collection if consumers add references to ND arrays to a batch list and and we've moved on with the tree, wouldn't those ND arrays still have a reference and would be collected later once the consumer resets the list? You know? Don't build ref count, stupid. Over retention. Yeah. Well, if they're copies, we make them not copies. Come on, though. Okay. Oh boy. Alright. Right in the mix on that. Finding seals it. Crops are copies, not views. Alright, well we can. Garbage collection guarantees nothing is free while referenced correctness. It does not guarantee a bounded, predictable working set control. 2 gaps remain and neither is closed by ref counting. The failure mode here is over retention, not premature free. Garbage collection frees promptly when the last reference drops, so the only way you blow memory is by accidentally holding a reference. 2 non-obvious holders in your design. The K-frame tracking window. That DQ is deliberate retention. If frame data node still carries frame numbers and keep frames for tracking means K plus 4 frames alive, even though detection is finished those pixels frames ago. Fix isn't ref counting, it's nulling the big field once the detection completes while keeping the small data node for tracking. Keep the small thing, drop the big thing. Yes, easy. Yes, I already said that. I already did that shit. Cross branch, emotion branch, batch. The face crop copies outlive their frame tree by design. So they're making a copy fine. But it means face crop pixels are governed by the batch's lifetime, not by the trees. Again, garbage collection does the right thing automatically once you've decided who holds the reference. Garbage collection gives you no back pressure. This is the one ref counting generally can't touch. Nothing stops an async producer from racing ahead and creating 500 live frames before a slow consumer dereferences them. Garbage collection will happily keep all 500 because they're still being referenced by the in-flight pipeline. The ceiling on the working set comes from the bounded queues. The producer blocks when the queue is full, not from garbage collection. Ah, yes. Ah, and so if I'm just firing for getting events, then it's gonna race ahead. Aha. Aha. Okay, aha. So if I'm just producing frames and firing for getting frame events, then we're going to race ahead on frames and get bogged down in memory. So we still need some element of async blocking by the consumers. I think though we need that to be Hi Pixel. We have a visitor. You want to say hello? Or did you just come in for your treat? Let's see if this works. I think it's gonna be sideways again. Yeah, sideways. I gotta figure this one out. Maybe I could do it. There's a way to do it. I'm not gonna figure it out. Hi. Do you want a treat? You came to see me. You want a cookie? You get a cookie for coming to visit. Okay. Coming to visit? Lonely up there, huh? I should probably cut out here in a minute because dogs have been all alone for a long time. Angela's not home. She's in the city today. Made NDI off. So I should probably take the dogs out and play with them or something because Poor Axel. He can't make it down the stairs. So he's all alone up there and he's sad and he's stressed out. Oh no. All right, let's finish this conversation, come up with the plan. I'll cut it out and then I'll do the implementation later or after. Offline. Off stream, I should say. I scroll back too much. All right. All right, so here's what I need to do, I think. I'm going to read this, and then I actually do need to step away because I think I need to think about this more, sort of pacing around. Your current async generator pipeline already has back pressure for free. A pull-based async for crop and person crops is demand-driven. The producer only advances when the consumer asks for the next item. The generator's lazy. It literally cannot race ahead because it doesn't run until pulled. The moment you switch from pull, async 4, to push, fire an event, you throw that away and have to buy it back manually with bounded queues. That's real often underappreciated cost of the event bus redesign. You trade the free back pressure of pull-based generators for the fan-out convenience of pub sub, and the price is re-implementing flow control. A pure pub sub bus that is truly fire and forget is unusable for a pixel pipeline. The bus has to be pull aware. Publishing blocks when the publisher subscribers are behind, at which each subscriber edge a bounded queue. The buses bounded queues with nicer routing. The slowest consumer paces the branch. When the person crop fans out to face detect and pose with one bounded queue each, the producer blocks when either queue is full, so the slower of the two throttles person cropping. That's correct, it's what keeps memory bounded, but it couples the two consumers' rates. Your decoupled versus memory knob is queue depth. All right, I gotta think about this some more. Yeah, it's right. Claude is right in this case. I do need this to be pull-based. So I need to think about how to do that without it being. And I also want to. I gotta think about this because the other thing that it's right about is that you don't want it to be, if we're doing real time, then what we're going to want to be able to do is everybody does what they can in the time allotted, and when time runs out, you move on. And that means that you don't want, if two queues are chewing through the same data, you don't want to say like, hey, pose takes really long, I can only afford to do it on one person, right? And then because of that, the generator for the thing feeding pose is blocked and not feeding new person crops, and the thing doing other things with person crops like face detection or something else, whatever it is now also waiting when it could have done like 50 or 100 in that same amount of time. So we got to think through. It's almost like we need It's almost like we need a pub sub with a timeout. I gotta go pace around and think about this. Anyway, making progress on this. It's a much bigger refactor than I thought. It's not just cleaning up the code. And I may actually want to back up a bit and focus on the code refactor before I focus on the memory and generator refactor. I think I may need to do that. And so I got to figure out like what's happening now. What I'm curious about is what's happening now when pose and faces want the same yields. How's that work? We got to think about that. But in any event, we are going to call it here. We'll probably come back on Tuesday and probably have something to show by then, hopefully. Oh, shit. But thanks for watching.